Welcome, y'all. Back to some more Algebra 3. This will be part 2 of 1.2 here. Now, we left off right here. We kind of did it ourselves. But I did mention there was a site called Desmos. So I wanted to show you that, to kind of go over this again. So, like I said, if you go to desmos.com, it brings up this screen. You can just hit graphing calculator. And there's just a nice little graphing calculator right here. So our first problem, it was f of x equals x squared minus 5. So let's look at that. So we put f of x equals x squared minus 5. If you error out of it, there you go, minus 5. And this is the graph. So we say, hey, what's the domain and range? The range is really easy. So let's look at the range first. The range, again, is what's the lowest point to what's the highest point. So the lowest point here is at 5. That's the absolute lowest point in this whole thing. 5. What's the highest point? This is where we said, hey, this goes to infinity. Look at that. If you zoom out, that sucker goes on forever. You can zoom out. I don't know how far let you zoom out. So let's see. It doesn't matter. Now it starts to look eventually like a straight line because it's just curving straight up. But no matter how far you zoom out, you still see that red line right there. So that's why I mean it goes to infinity right there. What if I can just hit? There we go. Center that back up. Oops, sorry. Oh, you just hit home. Hey, there we go. All right. So like we said, the range goes from its lowest point, which you put a bracket because it increases the range. It goes from -5 and then all the way to infinity, positive infinity, and then parentheses, because you can never technically include infinity ultimately because it's never ending. The domain is the same way because as this is going up forever, it's also going out forever. So you see this is slowly going out and it just keeps doing that forever. So it's going out to the negative side, range domain wise. It's going out forever this way and it's going out forever the other way, positive and negative. So that's our range. Our domain is negative infinity all the way to positive infinity. Right there. Now let's look at this problem right here, radical x plus 4. So let's come on here, and you can actually even add another one. You want to do it on the same one, but I don't want to, so we'll leave it like this. That one now, so f of x equals, and it was, what was it again? X plus 4. Radical, so you put the radical, so you hit shift, and then the radical. Ooh, where's the radical? On here. So this is how we'll do it. I think you can do it on here. Let's see. Oh, square root. That's what you put. You hit square root. There you go. You type in SQRT and put it in there. X minus or plus 4 plus 4. There you go. So x plus 4, as you see on here, same thing. Domain wise, the furthest it goes to the smallest it goes is -4, as you see right here. And the biggest it goes, like we've done it before, it goes forever, ever, ever to the right. So our domain goes from -4 all the way to positive infinity. Our range, same thing. What's the lowest it is? Technically, it's the lowest is at 0. This is the lowest it is. But the highest, because it's going forever up, it's also going forever to the right. It's going forever up as well. So we kind of see that right there. So just like this one here, domain, like I said, the lowest or the furthest furthest left is our -4, but it goes away to positive infinity. And then our range, same thing. The lowest it is 0, but it goes forever up to positive infinity as well. All right, so let's talk about the vertical line test now. The vertical line test is a test to determine, is this a function? Meaning, or a relation in a function. So remember, for it to be a function, functions, that's a horrible handwriting. Sorry about that. Let me do that again. Functions. A little bit better. Functions. For it to be a function, all values of x should only go to one y. All value of x. So x1, x2. Now you can have multiple x's go to the same y, but you cannot have y1, y2, and then put in x3. You cannot have an x go to two different y's like this to say this x goes to this value and this value. And you'll see right here. So if I do a vertical line, and let me actually get a good vertical line. So bam, and it's straight. Do I want this one? Yes, I want this one here. Good. Let's make it red. If I do a vertical line right here, bam. How many places does it touch this function is going on? It only touches once. Right this spot right here. No matter where I draw this vertical line, it will only touch it at one spot. Same thing right here. No matter how many vertical lines I draw, it only touches the function at one spot. So that's good. But let's look at this one right here. On a circle, it touches at two spots. So and I'm going to move it, kind of get a more. I'm going to move this over the -1 spot. Ooh, right there. Come on. Here you go. Ooh, right there. So that means when I put in my calculator, hey, the value of x is -1. What's my y value? It's giving me two answers. This one up here and this one down here. We have a positive answer and a negative answer. So that makes it a non-function. It's going to two different answers right there. So this is not a function. So this is just a vertical line to test. As you go through your homework, it'll ask you, is this a function, yes or no? And then if it is a function, what's the domain and what's the range? And this would be the best way to do it. Just do a vertical line. Does it touch two spots, yes or no? So this kind of determines the domain and ranges. Now, when we're given just the equation to determine what the domain and ranges is, can at any point can I put a number in here for x that will make this a no solution, that will give me a answer that it can't exist, that won't give me an answer? So for example, if I put in a -4, if I put in a -4, all right, I get negative. So let's kind of do the table. If I put in a -4, sorry, -4, -4 squared is positive 16 minus 2 is 14. Okay, if I put in a -5, what happens there? If I put in a -5, again, positive 25. Again, -5 to -5 is positive 25 minus 2 is 23. So, and the bigger the negative number gets, the bigger this gets as well. So, okay, there's that. If I put in a 0, what happens if I put in a 0? 0 squared, 0. But minus 2 still gives me an answer, -2. What if I do a negative or positive 1? 1 squared is 1, minus 2 is negative 1. So that's going up. What if I put a 2 in? 2 or -2, doesn't matter. 2. 2 squared is 4, minus 2 is 2. So as you can see right here, this thing is, as these numbers increase, this starts to increase as well. So at any point, is this a function? Yes. The answer is yes, it is a function. Now, what is the domain and range? So if it's looking at these numbers, what is the lowest, what is the, start with the range. No, the domain. Let's start with the domain. The domain. At any point, can I put in a value for x and it increase or decrease or get bigger? Yeah. So this is our negative infinity to positive infinity. There's not a single number that won't let me do it. Now our range, look at our range. As we're doing this, what is the lowest value this ever gets to? I could put a -1. Let's see what put a -1 in here. Double check -1 because we had a 0 that gives us my lowest number, but I put a positive 1. If I put a -1, -1 squared is positive 1 because -1 is -1, and then minus 2 is -1. So this is the lowest value it ever gets right here. So my range goes from -2, but then every number I put after that, it gets bigger. No matter how big this number gets, it gets bigger, and no matter how big it does on the positive side, that gets bigger. So that goes to positive infinity. You want to double check yourself. Always put in the calculator, double check yourself. So let's see that. So we want to look at that. So we have x squared. So shift 6 squared minus 2. There you go. The lowest value is -2. And then it goes forever up. And the same thing. It goes forever left and right. So let's look at this equation right here. So is there a number I can put in here? Now, what will make this particular problem a no solution or undefined? Remember, anything with a fraction, if I get a 0 down here, this makes it undefined. I cannot have a 0 down here at all at any point. I can have negative numbers, positive numbers, but I cannot have a 0. So what will make this, what value of x can I put in there that will make it 0? A positive 3. Yeah, if I put a 3 minus 3, that gives me 0. That is. So the way I think in Algebra 2 sometimes, depends on your teacher. Some teacher will teach you like, hey, all numbers, you can put every single number in here for x because you can have all the negative numbers and all the positive, but the number you can put is, this is called set builder. You have x such that x cannot equal 3. Like that. We're gonna do interval notation. So from going like from this place to this place and then from this place to that place. So like we said, you can put any negative number in there and you're good. So that means our domain for any value for x is negative infinity. I can put any infinity. But what number I can't put is that positive 3. So it goes from negative infinity to 3, and then you put a parentheses. We're introducing the union. Union means you're going to put two of these notations together. So union, and then starting from 3, and again, when you put the parentheses, it means it does not include the 3. You go from 3 all the way to positive infinity. So let's get a visual representation of that, what we mean right here. So our function such that 1 divided by, we say x minus 3. Ooh, look at that. So as you see this problem, let me zoom out so we can see the grand scheme of things. As we zoom out, it goes forever up, forever down, forever to the left, forever to the right, except right here at that 3. Let me zoom in a little bit more. There you go. This line rides by the 3 the whole way down, and it rides by the 3 all forever up, but it never touches the 3. No matter how close you get, it will never touch that 3. Let me zoom in. Ooh, wrong way. No matter what, this is the 3 line right here. All right. Let me double check. Yes, that's the 3 line right there. No matter how close it gets, it will never touch that value of 3 because, again, that's what we call a vertical asymptote, meaning the value cannot exist there. So this is the interval notation for that, for domain. Now let's look at range. Graph-wise, what number, range-wise, does it go? It goes forever down, forever up. So unlike the other one, it does go forever up and forever down. So our value for range, we can get any number in here, be fine. So range is different. So range will be negative infinity. Ooh, that's a horrible infinity. There you go. To positive infinity. There you go. All right, let's look at this problem. Same idea here. Okay, we can't get a negative in here. I mean, we can't get a 0 down here. So we for sure can't have negative 2. Negative 2. But also, we got to take into consideration, there's a radical here. So as we did first semester, the things you can't have down here as a radical is 2 things. You can't have a 0. I mean, you can have a radical 0, which is 0 still, but you can't have anything less than 0 as well. You can't have any negative numbers down here. If you have a negative in a radical, that makes it imaginary. You can have a negative answers. Remember, when we're doing these, we'll have like negative 1 really equals I. I think we did it this last semester. Remember, I know you've done it in Algebra 2, but we'll talk about it again. You can't have a negative in there. So that's our issue right here. We can't have a negative. So what value? So let's kind of look at this equation. Let's look at the picture of this first and kind of get the idea. We're doing 1 over x. Square root x plus 2. X plus 2. Ooh. Kind of zoom out. I should zoom in. What is it doing as well? What is the lowest value it can be? Almost 2. As you see, just like the last one, it travels along the 2 but it will never touch it no matter what. Zoom in some more. See, it will never touch it. It may look like it does, but it never does. That's what we call a vertical asymptote. But this one also has a horizontal asymptote right here. Your range, just like the last one, it gets close to, but it can never be. Ooh, let's go in. It gets close to, but it can never be 0 as well. So, just like before, what's the lowest value? Oh, let's go back. Domain, left to right, starting with left. Our domain, what's the smallest value we said it could possibly be? Going back to the picture here, the lowest it can possibly be is -2, but it can't be -2. So that's where we put a parentheses, -2. It can be -1.99999. That's what we say, parentheses -2. That means close to -2, but not -2. But it goes forever, as the picture says, it goes forever to the right. So it goes all the way to positive infinity. Right there. And then, just like before, you can't have a 0 down here ultimately. So the lowest it can be, as you see right here, your range, it gets close to 0, but it never touches 0, but it goes forever up. Right there. Okay, so it's important to kind of see these. So that being said, let's kind of look at these right here. We're going to guess the domain and range just strictly by the picture. Okay, so strictly by the picture, we can go ahead and assume there's arrows at the end right here since it keeps going forever. Same thing right here. And then forever this way. All right, so look at this first problem. What is the lowest, or start with domain, left to right? Is there an endpoint to either one of these? Because again, it's going sideways, so it goes sideways, but it's also going forever. It's going forever to either way, so we can go ahead and say domain right here is -infinity to positive infinity. Range, what's the lowest and highest? Same thing. It goes from -infinity to positive infinity. Okay, so look at this next one right here. Now here, domain-wise, what's the furthest left it goes? What's the smallest it can possibly be? That spot right there. That is -1, -2, -3, -4. -4 is the smallest it can be. So bracket, because it does touch that -4. -4, and what's the furthest right? Goes forever. So that's our positive infinity. I want you guys to pause and kind of do these other two right here. Okay, so I'm going to finish this. Range-wise, what's the lowest it can be? What's the lowest value? It stops right here at this line, which has a value of 0. So 0 is my lowest value. What's the highest? Again, it's going forever up, so positive infinity as well. It's okay to have answers like this and multiple answers like this. As you go through your homework, you'll see your job is to notice what is the numbers I can and can't put. There's no restriction. It's forever. Now, other things you would see that we have not talked about on here yet is you'll see what's called a open hole, almost like a hole, just open hole as thing. So they'll draw it, and there's an open hole, and they'll continue. That right there is also a value that cannot exist. So regardless of where it's at, you'll do a union, as we'll do here in a bit. We'll show you one of those union sets. All right, let's look at this one right here. What is the lowest value? So left to right, domain, change colors, domain-wise. Furthest left, furthest right. Furthest left, this point right here. So this is 2 right here. That means these are halves. So half, 1, half, 2. So this is the 1. So it's a positive 1. Oops. Positive 1. And what's the highest? 4, 5. So this does have a domain, a set domain. Our range will be, what's the lowest? The lowest is right here. That's our 0. And our highest is up here, which is at 2. Right there. Now let's look at this one right here. So this is a 5 by 5, so it's 1, 2, 3, 4, 5. Each one's 1. So domain-wise, what's the furthest left? It goes forever this way. So it goes -infinity What we gotta watch is how you see how it's going this way. As it's coming towards the right, it drops, and it drops along this line right here. That means it cannot include that value of x. That's where our vertical asymptote is. So that stops at 2, and then we put a parentheses, but it doesn't include 2. And this is where we do our union. Union means we're going to bring in the other half. We're going to talk about this half now. So, because it does break it up into 2 different functions almost, but it's 1, but almost 2. All right, union, and then it starts up right here as it comes back down. It starts up at along 2, but doesn't include 2, but then it goes forever to infinity, positive infinity. There you go. Range is a little bit easier. It goes forever down and forever up. So range, forever down, so negative infinity, and forever up, positive infinity. And there you go. Hopefully that helps y'all as you do the homework. But I will talk to you on a different day. Bye.